for a second. You go out and buy a $1 million Formula One car.
Okay, nice. I like where this is going.
Right. It's an absolute engineering marvel. So
Yeah.
you take this masterpiece, you haul it down to the local marina, and you try to use it to tow your fishing boat.
Oh, man. Yeah, that's not going to end well.
No, it's a disaster. I mean, the engine is incredible, but it doesn't have a hitch. The suspension is completely wrong for the task.
Right.
And, you are basically guaranteed to completely destroy the transmission the very second you hit that boat ramp.
Exactly. It's astonishingly powerful, but the fit is just completely terrible.
Exactly. And that's exactly why we're doing this deep dive today. Because, if you're navigating the business world right now, you're watching a massive amount of people basically buying F1 cars for their fishing boats when it comes to AI.
Yeah, they really are. And to get into this, we are unpacking a really fascinating set of notes today. These are from the May 8th, 2026 session of the Chicago AI Mastermind group.
Which is a great source, by the way.
It's fantastic. I mean, these are enterprise developers who have entirely moved past that sort of honeymoon phase of artificial intelligence.
Right. The hype cycle is over for them.
Exactly. They aren't just experimenting with fun prompts anymore. They are building actual rigorous enterprise workflows. And their main mission in this session, and our mission for you today, is to really kill that exhausting question of which AI model is the most powerful.
Right, because everyone asks that.
Constantly. And they want to replace it with the only question that actually matters, which is, does this specific tool actually fit the work?
Okay, so let's dive right in and unpack this. Because to figure out what tool fits, we really have to break this habit of treating AI like it's this single magical monolith.
Oh, 100%.
People out there still use terms like AI, large language model, and automation completely interchangeably. Like it's all just one big Swiss Army knife that's equally good at everything.
Yeah, and a member of the mastermind group, Paul, he made a really crucial distinction here. He pointed out that an LLM is fantastic if you want it to write a haiku, right? Or if you need to summarize a massive block of text.
Sure, it's great at that.
But if you look at a highly regulated field take fraud detection in finance, for example, the process is entirely different. Fraud detection is not a chatbot popping up on your screen saying, hey, looks like suspicious activity.
Right, like a friendly little assistant.
No, not at all. It is a rigid, deterministic, analytical tool. Its output isn't a conversation, it's a spreadsheet and a red flag.
Which means the mechanics under the hood are completely incompatible. Because an LLM is a language engine. It's not a calculator.
Exactly.
When an LLM looks at a math problem, it's not actually calculating the equation using rigid logic. It's predicting the most statistically likely token to follow the previous tokens.
It's guessing.
Right. It's literally guessing what the answer should look like based on its training data. So if you ask an LLM to do deterministic rules-based math for enterprise compliance,
You're using the wrong vehicle entirely.
you're at the boat ramp with the F1 car.
Yeah, and this mismatch in mechanics, it leads directly into what the group spent a lot of time discussing. They called it the 80% trap.
The 80% trap. I love that phrasing.
It's so accurate. It's basically this illusion of polished output. So you ask a frontier model for a market report, and literally in 3 seconds, it generates this beautifully formatted, highly authoritative sounding document.
Right. It's got bullet points, bold headers.
Exactly. It looks completely finished. But Paul warned the room that this polish is actively hiding things. It hides missing edge cases, unverified assumptions, and just complete hallucinations.
Okay, but I have to play devil's advocate for a second here.
Go for it.
For you listening, you might be thinking what I'm thinking. If a system gets me a perfectly formatted rough draft in 3 seconds, isn't getting 80% of the way to the finish line just a massive productivity boost?
It feels like one, sure.
Right. Like the human can just come in and clean up the remaining 20%. So labeling a massive head start as a trap seems, I don't know, maybe a bit overly pessimistic.
Well, that is exactly the counter-argument that always comes up. But another member, Joe, who works in the really high-stakes payment sector, he reframed this perfectly around the concept of risk concentration.
Risk concentration. Okay, unpack that.
So the danger isn't about the grammatical quality of the formatting. It's that if that flawed 20% happens to be the critical path in a financial transaction, the output isn't almost done. It's actually a massive liability.
I see. Meaning, if the AI hallucinates a summary of a boring marketing meeting, nobody really cares.
Right. No harm done.
But if it hallucinates a decimal point in a wire transfer,
Exactly.
or it hallucinates a vital clause in a legal contract, the business fails. It's like the difference between a typo in a novel and a typo in the blueprint for a load-bearing pillar on a bridge.
That is a perfect analogy. And the thing is, the polished nature of that 80% actively disarms our critical thinking. That's the trap. It gives you a false sense of security.
Because it looks so good.
Right. Because the document reads so fluently and looks so professional, the human reviewer is just lulled into not scrutinizing that load-bearing 20% closely enough. A perfectly formatted lie is infinitely more dangerous to an enterprise than an obvious, glaring error.
Wow. Yeah, perfectly formatted lie. And that danger scales up catastrophically when you move away from just writing reports and start asking the AI to write software.
Oh, yeah. That's a whole different level of risk.
Because if it guesses a number in a spreadsheet, you maybe lose a lead. But if it guesses a software dependency, your entire application crashes. Which brings us to a major point of contention in these session notes, the reality of vibe coding.
Right, vibe coding. This has become a huge trend lately.
It really has.
For those who haven't heard the term, vibe coding is basically the practice of a non-technical user prompting an AI to quickly spit out working software or scripts. You just give the model the general vibe or description of what you want.
Just natural language.
Exactly. And it writes all the code for you, even if you have absolutely no idea how to read the output.
And the mastermind group just threw serious cold water on this practice. I mean, Eric introduced a metaphor that I found incredibly illuminating.
The evolution one.
Yes. He said vibe coding is basically like evolution. And evolution, it doesn't plan ahead. It doesn't care about elegant design or long-term structural integrity.
Right. It just wants to survive.
Exactly.
Yeah.
It just randomly mutates and brute forces iterations until something manages to not die. And vibe coding does the exact same thing.
Yeah, the AI will write a function, realize it's broken, and then write this messy patch on top of that patch until the program finally compiles.
It survives.
It survives, but there is no elegant architecture beneath it. Two other members, Jennifer and Paul, they really highlighted the massive technical debt this creates.
Because you don't know what it actually built.
Right. When that vibe-coded application inevitably breaks 6 months down the line and you don't actually know the language it was written in.
You're toast.
Yeah. You have zero chance of untangling the mess. You basically traded a week of speed today for a decade of maintenance nightmares tomorrow.
Which is terrifying for an enterprise. And that same fundamental problem, trusting the machine to just make it work, it bleeds heavily into data workflows too.
Oh, absolutely.
We see this all the time when an AI is tasked with structuring messy enterprise data and it encounters a gap. Like say it's processing a massive client database. Instead of flagging the missing information, the model's probabilistic nature kicks in. It just desperately wants to complete the pattern.
Yeah, Joe warned the group about this specific behavior. He pointed out that if an AI tries to fill in a missing data point, it might not technically be hallucinating out of thin air.
Right, it's not just making up nonsense.
No, it's making a highly educated, probabilistic guess based on the surrounding context. But if that guess is wrong, the error propagates quietly and just throws your entire downstream analytics completely off track.
It is exactly like having a really overeager assistant.
Yep.
Like you tell them to clean up a client spreadsheet for a huge presentation, and instead of just admitting, hey, I don't have the phone number for this client, they fear looking incompetent.
So they just guess.
They just type in a number that looks like a phone number so the cell is filled. The appearance of completion is prioritized over the actual accuracy of the data.
And in a complex enterprise system, once that inferred guessed data mixes in with the actual hard data. Yeah, you can no longer tell the difference. Your entire data set is compromised.
So how do they fix it? I mean, they didn't suggest banning AI from data workflows, right?
No, not at all. Instead, they focused on workflow architecture. Paul laid out this really strict design requirement for the group regarding data provenance.
Okay, provenance being the paper trail of origin.
Exactly. The rule is that if your AI system fills in a data gap, it cannot just drop the number into the cell and move on. The user interface and the underlying system must be designed to show exactly why it filled it in.
So it needs to show its work.
Yes. It needs to tag that specific data point visually, list the assumptions it made, and provide the reasoning or the evidence right next to the cell. It has to clearly delineate what is original, hard data, and what is probabilistically inferred data.
That makes total sense. And that really moves the conversation away from treating AI as this magical black box and towards building robust governance around it, which actually introduces a really fascinating pivot in the mastermind session notes.
The fencing idea.
Yes. If we know we cannot completely trust a probabilistic model to write production code or fill data gaps without a strict paper trail, We have to look at how to constrain the model itself. We literally have to fence in its brain.
And that requires making some really hard architectural decisions about the models you choose to deploy. The group spent a lot of time debating the use of massive cloud-based frontier models versus smaller local models that run directly on internal hardware.
And the notes detail this real-world test Paul ran that highlighted this trade-off so perfectly. He used a local AI model, completely disconnected from the cloud, running entirely on his own machine.
Right.
And he asked it to write a simple 5-line haiku.
Just a haiku?
Just a haiku. And it took 7 full minutes to generate. 7 minutes.
Mm-hmm.
But Paul summarized the enterprise calculation in one sentence: your speed for privacy.
Yeah, it's a stark trade-off. Cloud models offer staggering speed and vast capabilities, but you are sending your proprietary data out into the world, often to be trained on by the provider.
Which is a huge compliance risk.
Exactly. Whereas local models offer total ironclad privacy and control, but you are bottlenecked by the physical hardware sitting in your own server room.
But, the concept of constraining the AI went far deeper than just where the model physically lives.
Right. The group intensely discussed how to constrain what the AI actually knows.
Because, and this is a massive public misconception, as Eric defined them in the session, large language models are not databases of facts.
No, they aren't.
They are just probabilistic weighted entities. When you ask a general model a question, it is not looking up the truth in some digital encyclopedia. It is mathematically calculating what a true-sounding sentence looks like based on the billions of parameters it ingested.
Which is exactly why they hallucinate confident lies.
Right. So to fix this, the Mastermind group strongly advocated for architectures like retrieval-augmented generation, commonly known as RAG, or tools like NotebookLM.
Yeah, RAG is huge right now.
For you listening, if you aren't familiar, RAG is basically the mechanical solution to the hallucination problem. Instead of relying on the model's vast, kind of blurry memory of the entire internet to answer a query, RAG forces the AI to take an open book test.
That's a great way to put it.
You create a secure folder of your own verified documents, and the system is forced to search that specific folder, retrieve the relevant paragraphs, and only use those paragraphs to generate the answer.
And to do this effectively, the enterprise uses something called a vector database, which is really cool. A vector database doesn't just store documents like a normal hard drive. It translates text into mathematical coordinates in space based on meaning.
Coordinates based on meaning.
Yeah. So the concept of Apple the fruit is stored mathematically very far away from Apple the computer company.
Oh, that makes sense.
So when the user asks a question, the RAG system finds the coordinates of that question and pulls the documents located in that exact mathematical neighborhood. It literally forces the AI to only look at the exact coordinates of your internal company truth.
I love that visual of coordinates in space. But stepping back for a second, there's an inherent tension here, isn't there?
What do you mean?
Well, the whole selling point of these massive frontier models is that they have ingested the sum total of human knowledge on the open web. So by forcing it to only read from a highly restricted vector database, aren't we intentionally putting this incredible technology into a tiny box and, limiting its potential?
Well, yes, we are putting it in a box, but Abe pointed out why that box is absolutely mandatory for enterprise survival.
Good.
By constraining the AI, you establish a governance layer. You can force the model to interact solely with reputable peer-reviewed journals or highly vetted internal technical manuals that you select.
You don't want it pulling from Reddit.
Exactly. You aren't crossing your fingers and hoping the model's probabilistic engine correctly weighs a medical journal over some random conspiracy thread on a forum.
Yep.
You are defining the boundaries of its reality.
You define the reality.
Wow.
But that exact power led to a slightly chilling warning from Joe in the session notes. He told the group, someone has to define what is the prioritization in truth.
Yeah, that line really stuck out to me. It's a profound philosophical and practical problem. If you build a vector database that only pulls from approved sources, somebody in your organization has to approve those sources.
Right.
Controlling the data means you inherently own the bias. You are no longer just utilizing an objective software tool. You are actively curating the worldview that the tool operates within. And if your curation is flawed...
the AI will flawlessly execute flawed logic.
Exactly.
That is a massive responsibility, and I think it perfectly sets up the final and perhaps most critical theme from this Chicago Mastermind session, because we can meticulously curate the data sources.
Yeah.
Right? We can control the model architecture. We can build these complex ARAG systems and demand UI provenance.
Sure.
But Absolutely none of that matters if the human user on the other side of the screen is treating the AI like something it fundamentally is not.
Yeah, the human vulnerability factor. The session notes took a surprisingly heavy turn here when the group started discussing this growing risk of people treating these text engines as sources of profound wisdom.
Yeah, Abe explicitly mentioned his fear of seeing lay users asking uncredentialed AI models for major life and career advice and actually restructuring their lives based on the output,
And Eric noted a deeply concerning trend where teenagers are increasingly using chatbots to get what looks and feels like therapy.
which is completely unclinical and unregulated.
Completely. Dennis, another member of the group, drew a very stark, non-negotiable boundary for everyone. He just said, don't use it as a psychologist.
Right, don't do it. And here's where it gets really interesting to me, just on a psychological level. It highlights this massive cognitive blind spot we have. Because as these frontier models become faster and more conversational, they feel increasingly human.
Oh, definitely.
We are biologically hardwired to believe that fluency equals expertise. Think about it. For the entirety of human history, the only thing that could speak with perfect grammar, nuanced vocabulary, and structural logic was a highly educated human being.
Right, there's no other option.
So our brains automatically associate articulate speech with deep underlying reasoning. And now, for the very first time ever, we have a machine that perfectly mimics the speech without possessing an ounce of the reasoning.
But our brains still grant it the authority of a mentor or a doctor or a therapist.
Exactly. We confuse a sophisticated language prediction engine with an empathetic reasoning engine.
And when you are navigating high uncertainty personal decisions or high stakes enterprise decisions, projecting human authority onto a mathematical algorithm is incredibly dangerous.
Dangerous.
The more human a system feels, the more rigidly we have to define and enforce what it is actually qualified to do.
So how do we wrap our arms around all of this? I mean, from the dangers of vibe coding and risk concentration to local models, vector databases, and these human psychological traps, how do we actually operate going forward?
Well, it all distills down to the ultimate operating principle of this session. It was summarized perfectly by a member named John. He told the room, right-size your solution to fit the problem.
Right, size your solution.
Start with the exact outcome you need, understand the mechanics required to get there, and then, and only then, select the tool.
And Paul asked a related question that I honestly think should be printed out in bold letters and taped to every developer and manager's monitor right now. He asked, do you even need AI for that?
It's the best question you can ask.
It is. Sometimes, a simple deterministic spreadsheet with a locked formula is infinitely better, safer, and faster than spinning up a massive neural network.
Yeah, John provided a fantastic closing metaphor to really anchor this. He said to think of the large language model as highly intelligent horsepower.
Okay, horsepower.
You can harness that immense horsepower to pull a heavy, unstructured workload, like, say, sorting thousands of raw customer reviews. Or you can use that horsepower to help you build a specific tool.
Right.
But, he cautioned, the model itself should not be the tool doing your final financial analysis.
Because it's the difference between using an AI to help you write the Python code for a customized calculator versus asking the AI chatbot to just guess the math for you in the chat window.
Exactly. One uses the horsepower to construct a reliable, deterministic tool. The other lazily relies on a probabilistic engine to do deterministic work.
Which leads right back to the 80% trap.
Full circle. So, to really synthesize the core takeaway from this deep dive for your own daily workflows, you just have to fundamentally change your perspective.
Yeah. Stop asking which AI model should I use and start asking what specific mechanical work actually needs to happen right now. You must match the mechanism of the tool to the risk profile, the context, and the reality of the workflow. And as a direct practical application of the Mastermind Group's advice, we actually have a challenge for you listening today.
Yes, do this today.
Audit just one single task you are currently using an LLM for in your daily routine. Look closely at the actual mechanics of that task and ask yourself, is a probabilistic language model actually the best fit here?
Right. Or would a simple deterministic rule, a basic checklist, or just a standard internal search tool actually be faster, completely safe from hallucinations, and infinitely more reliable?
Audit your workflows. Make sure you aren't using an F1 car to tow your boat.
It is a necessary reality check for anyone trying to build lasting systems right now.
It really is. But before we officially wrap up, I want to leave you with one final, slightly provocative thought to mull over on your own.
Oh, here we go.
The entire goal of this mastermind session, and really the overarching goal of enterprise AI development right now, is to constrain the system.
Right. Fence it in.
Exactly. The objective is to strictly control the data sources, define absolute boundaries, force the model into rigid vector databases, and lock it into highly monitored workflows to entirely eliminate risk.
Yes, the goal is to make a wildly unpredictable technology safe, predictable, and legally compliant.
But here is the deeper question to consider.
Yeah.
If we succeed, if we perfectly sanitize and constrain these systems to only ever do exactly what we expect them to do within our predefined, heavily governed boundaries,
Yeah.
do we risk engineering out the very serendipity, the massive creative leaps, and the surprising happy accidents that made artificial intelligence so revolutionary to begin with? If we force the F1 car to only ever drive at 30 miles per hour on a perfectly straight, walled-in track, do we lose the magic of the open road? Something to think about. Until next time, thanks for taking this deep dive with us.